All right, today we are learning about segments and their measurements. And so before we get started with our segments and their measurements, we need some common language and we need some words. So, vocabulary. So the first vocabulary word that we have is congruent. And we show congruent with this symbol. It's an equal sign with a little squiggle on top, and that means congruent. And so congruent means same size or same shape. And so here I'm going to draw a segment. We'll call this segment A, B. And I'm going to copy and paste it. So we know for sure that AB and CD are the exact same size and they're the exact same shape. To show that in my picture, we can use tick marks. And so if I put a tick mark here and here, that means that AB is congruent to CD. And so tick marks show congruence. And so what does bisect mean? Bisect means to divide a segment, angle, or shape into two equal parts. And so we're going to draw a segment. This is segment XZ. And segment XZ is going to get bisected by point M. And so to show that M is exactly in the middle, dividing segment XZ into two equal parts, we're going to use tick marks to show that XM is congruent to MZ. And so a bisector is a line or point that bisects an angle or line segment. And so we're going to draw another segment, and this time, instead of our bisector being a point, our bisector is going to be a line. And so this line divides our segment into two equal parts. And so now we're going to discover how to find links on a number line. How to find segment links on a number line. So here, notice we have GI and it does not have a bar on top. And so if there's no bar on top, that means how long is GI? Well, we can go up to our number line and simply count. How long is segment GI? Well, it looks like it is 2 units long. So how long is segment HK? HK is 1, 2, 3 units long. And so we're going to add U for units, no naked numbers. Everything gets a label. And so finally, another way that we can determine the length of a segment on a number line is by subtracting. We're going to take the bigger number and subtract the smaller number. And so for segment JO, the bigger number is 1, coordinate is 1, and we're going to subtract the smaller coordinate, which is -4. 1 minus -4. So what happens when we have a double minus? Whenever we have a double minus, that turns into a plus. So we have 1 plus 4, meaning that JO is 5 units long. And if you want to count and confirm that, you can count and confirm that. 1, 2, 3, 4, 5. Now to find the length of IM, we are going to subtract again. So we have I, we have M. Which one is the bigger number? The larger number is -1. It's closer to positive. And we're going to subtract the coordinate I, which is -5. And so we have -1 plus 5, and that is going to give us 4. IM is 4 units long. And so now we have this question: what point is 2/3 of the distance between I and O? So let's count what is the length of IO. I is here, O is there, and there are 1, 2, 3, 4, 5, 6 units between I and O. And so we need to think, what is 2/3 of 6? 2/3 of 6, 2/3 times 6 is going to be 4. And so instead of going the whole distance from I to O, we're going to go just 2/3, which is 4 units from I to O. So 1, 2, 3, 4. We land at point M. Draw the scenario. Anytime we see the word between, that word means that we are going to be collinear with our other points. Now I have to double check if collinear has one L or two. Let's go double check, because my spelling is always a little, yep, 2 L's. Boop. So K is between R and T. So we're going to draw a segment R, T, and K is somewhere in between. It doesn't have to be in the middle. It can just be anywhere in between as long as it's on the same segment. So here's K. And so something that is true about this picture is that RK plus KT equals RT. Let's draw our next scenario. Y is between X and Z. So here's X, here is Z, and Y is somewhere in between. So now we're asked these questions. We're asked to figure out if RK is 12 and KT is 13, this is not drawn to scale, that's okay, then find RT. So if RK is 12 and KT is 13, find RT. So what are we going to do with these two numbers to figure out the length of RT? Well, I hope you said that we're going to add them together, because RK is 12 and KT is 13. And so that would mean that RT would be 25. RT is 25 units long. All right, now let's look at this scenario. If XY is 8 and XZ is 22, find YZ. So this time, instead of looking for the whole, we're looking for a part. And so we're told that XZ is 22 and we need to find yz. And so in order to find the length of yz, instead of adding, this time we're going to subtract. 22 minus 8 . 14. And so yz is 14 units long. And so a concept that is present in both of these problems is the idea that part plus part equals whole. Again here, part plus part equals whole. And so the segment addition postulate is a postulate that says exactly that. So given 2 points, A and C, if B lies between A and C, then part plus part equals whole. Let's draw the scenario. So given 2 points, A and C, if B lies somewhere between, then part plus part equals whole. And so this is a concept that is going to drive our learning for the next couple of problems. And so here we have segment MP, and N is between M and P. And so we have variables this time. Instead of just having plain numbers, we have variables, and we're asked to find X. Well, something that is true with this problem is that MN plus NP equals MP. So let's plug in our pieces. How long is MN? MN appears to be 3x plus 2 units long. And how long is NP? NP is 18 units long. And our whole, NP, is 5x units long. So now we have this equation that we can solve. Our first step in solving this equation is combining like terms. And so 3x plus, instead of 2 plus 18, we can combine those to make 20 equals 5x. And so we want to get x by itself. Right now we have x's on both sides. And so to get x by itself, we need to move all our x's to one side. We can either subtract 3x from both sides, or we can subtract 5x from both sides. The best option here is to subtract 3x from both sides. Subtract the smaller x value. These cancel out, and we're left with 20 equals 2x. Divide by 2 on both sides, and we find that x equals 10. And so now it says MP equals what? And so notice we have MP without the bar, so that means what's the length of MP? And so if MP is 5x units long, then that means that MP is 5 times whatever we got for our x, which was 10, and so MP is 50 units long. Let's try out our next problem. Reading all of our information, first we're told that AC is 21 units long. And so if AC is 21 units long, that means our whole is 21. What is true in this problem is that AB plus BC equals AC. Part plus part equals whole. So let's set up our equation. 2x plus 10 plus x minus 4 equals the whole 21. We must combine like terms. We have 2x plus x, and we have 10 minus 4. And so when we do that, our 2x plus x is going to make 3x, And our 10 minus 4 is going to make a positive 6. What is our next step? Hopefully you recognize that we need to subtract 6 from both sides. When we subtract 6 from both sides, we find that 3x equals 15. And so now we need to divide both sides by 3 to find that x equals 5. So what's the length of AB? AB is going to be 2 times 5 plus 10. And so 2 times 5 is 10 plus 10 is 20 units long. And BC is going to be 5 minus 4, therefore 1 unit long. And let's check our work. We're told that the whole is 21. We just figured out that this is 20 and this is 1. And 20 plus 1 is 21. So now we are going to move on to a slightly different concept. And so now we're going to look at midpoints. So for a midpoint, the midpoint is the point equidistant from the endpoints of a line segment. And so let's draw our line segment. We're going to draw a line segment A, B. And our midpoint M is going to be equidistant right in the middle of A and B. And so whenever we have a midpoint, instead of the concept being part plus part equals whole, our concept is part equals part, because AM is equal to MB. And so to apply that concept, let's go ahead and set up our problem part equals part, because XM, the tick mark, shows us that XM equals MZ. Therefore, 2x plus 35 equals 5x minus 22. And so whenever we have x's on both sides, we always are going to move our smaller x over. So we're going to subtract 2x from both sides. These two x's cancel out, and we're left with 35 equals 3x minus 22. We're going to add 22 to both sides, and we get 57 equals 3x. Divide by 3 on both sides, and we find that x equals 19. Now let's find the length of xz. Now this is going to be a little tricky because it's a little bit more than just plugging in our x. Let's plug in our x, 19 plus 35. I'm going to use a calculator for this. Two times 19 plus 35 tells us that half of our segment XZ is 73 units. But we don't want half. We don't want XM. We want XZ. And so what we have to recognize is that if this is 73, then MZ is also 73. And 73 plus 73 is 146 units. All right, let's do one more. Really, we have two more, but let's do this next problem. M is a midpoint. How do we know? Hopefully you said the tick marks. The tick marks tell us that M is a midpoint. And so if M is a midpoint, we're going to do part equals part. X plus 20 equals 5x minus 4. We want to get x by itself. And so first we need to get our x's to one side. So I'm going to subtract x from both sides. These x's cancel out, and I'm left with 20 equals 4x minus 4. We're going to add 4 to both sides. These cancel out, and I'm left with 4x equals 24. Divide by 4 on both sides, and we're left with x equals 6. X equals 6, but the problem does not ask us simply to find x. We need to find the length of AC. Are we finding the length of half or whole? We're finding the length of the whole segment. And so AC, first we're going to plug into half. X equals 6, and so we have 6 plus 20, meaning that AM is 26, and if AM is 26, then MC is also 26. And 26 plus 26 is going to give us 52. AC is 52 units long. So our last problem is a mixed method problem. So what does that mean? That means we're going to use part plus part equals whole, and we're also going to use part equals part. So the first thing we're going to do is recognize that M is what? A midpoint. We know that M is a midpoint because we have tick marks here and there. But we're not going to immediately start with part equals part because that's not true. We cannot say that AM is the same as AB. But we can say that AM is the same as MB. So AM, 2x plus 7, is the same thing as MB. So MB is also 2x plus 7. And so now that we know that, we can use part plus part equals whole. 2x plus 7 plus 2x plus 7 equals 7x plus 2. So the first thing we need to do to start solving for x is we're going to combine like terms. 2x plus 2x is going to give us 4x, and 7 plus 7 is going to give us 14. So we have 4x plus 14 equals 7x plus 2. We have x's on both sides, so we need to subtract our smaller x. So we subtract 4x from both sides, and we end up with 14 equals 3x plus 2. We're going to subtract 2 from both sides, and we're left with 12 equals 3x. Divide by 3 on both sides, and x equals 4. X equals 4. All right, well, that concludes our notes for today. Thank you so much for completing your notes with me, and I hope you have a great rest of your day.